Sure. Yeah, I like my teeth. Yeah, usually I put it in my bag during the weekend. It looked like I went to the top. So already using that camera. Yeah, we can probably return that one. Sure. That's you. Yes, so I don't think I need mine on that. Now, I don't know why you're doing this game. So, like, really, this is just. Oh, it's not no cool. There's still having to know that. I don't know. I haven't tried since that day. It's the consumption. Can you mute that?
Here. I could be from anywhere once I'm on the iPad. No, I'll talk through the iPad instead, because if we're doing the recorded, I'll just record. It'll catch my voice on here, so it'll be fine. Let's go to this real quick. So, yeah, I figure I have to do this. Listen to this. Yeah, so I just have to delete this. Okay, and then try it again. It's weird because the one from the other day, I try to re-upload the file, but the other one keeps popping up with all the solutions. So I have to take that out. Let's go back to Zoom. Let's go to share screen.
Nice.
Yep. And then you're recording?
Yeah.
Okay. Cool.
I'll set it automatically.
All right, good. All right. So we're up. Good morning, everyone. No, I'm using this. They can hear me through here.
Yeah.
Want to hit the lights?
There's a camera, by the way, over there.
Gotcha.
You sure you don't want to use this one?
No, I'm fine. We'll use this.
I'm gonna get my laptop.
All right. Let's keep the chat out. Chat on the side. Okay, so I guess I'm all set and we are ready to begin. So I won't waste any more of your time. We're gonna get started, okay? Welcome to our Math 171/172 review session. We had one on Thursday, and we have, again, another one today. So if you were here on Thursday, some of the problems, or if you were here on Thursday, you would have seen how to solve most of the problems. So it's basically going to be another extra review for you, a refresher. So I have the following directions regarding our review session. The purpose of review session number 1 is to prepare students for their upcoming examination in either Math 171 or Math 172. During the review session, we will discuss and explain how to solve problems in the following topics: distance formula and circles, lines, which will cover the slope, equations, and graphs, functions, which is the algebra, limited domains, and graphs. Please note that the problems that are going to be highlighted in yellow are examples of similar problems that you see again on the final exam. So it's very possible that some of the problems that I'm going to do today, namely the ones that I'm highlighting, might not be on your first exam, but it's definitely going to be there again for the final. So it's best to prepare from now for it. Do anybody have any questions before we begin going over the problem sets that the solutions to the problems that I have here in the slides? Oh, by the way, this is yours. All right. Any questions? Okay, so, that's a good question. Yes, there's going to be the last Thursday's meeting was recorded. You will definitely get access to it very soon. Today, most likely today. We're just waiting off after this meeting is over, so that way we can post them simultaneously. You're welcome.
Can you ask somebody to speak to see if we will get sound back?
Oh, sure. Can I have a volunteer, please, from the Zoom meeting to please just talk through your mic just so that we can determine if we're going to get feedback. Not feedback, but the sound back. If you can hear you guys. You just say hello.
Good morning.
Good morning. We can hear you. Mahmood. Okay. Alrighty. So I guess where would the links for the meetings be posted? The links for the meetings would, Rafael, the links for the meetings in terms of the recordings is going to be available through our website?
Yes.
It's going to be available through our website.
We'll send it via email to all of them.
That's right. And there will also be an email sent to everyone that's enrolled in basically Math 171 or Math 172. You're welcome, Joseph. Okay, so as I'm going through the problem set, please volunteer, answer any follow-up questions that I ask you, namely like, something arithmetic, something like formula or an explanation. And if you do have any questions, please let me know. It's best that you let me know if you unmute your mic. Yes, sometimes it's just best to ask your questions if you unmute your mic. I can follow along pretty nicely that way. All right, so let's begin. So problem number 1 states find the distance between the two given points, -4, -1, and 2, -3. If necessary, express the final answer in simplified radical form. So I guess I was blocking our view here, so I'll just push this on this side. Excuse me. Alrighty, so do anybody know the formula used to find the distance between two or the given order pairs? Let's begin with that. Yeah, somebody had their hand up. You can go ahead and answer the question.
I believe is y2 minus y1 or divided by x2 divided by, minus x1.
Unfortunately, no, not for this problem. That would be used.
Oh, this is distance. Sorry.
Yeah, this is distance. Okay. That's right. So, the other form, go ahead.
Yeah, so no, man, I misread the question. So it would be y2 minus y1 squared plus x2 minus x1 squared, and then you have to square root the whole thing.
That's right. So let's just write out the distance formula. We say d is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. That's essentially your distance formula. Okay, so the way that the distance formula works is that we can label our points and then plug things in. So -4, -1 is, we can label it as x1, y1. The second order pair 2, -3, we can label it as x2, y2. And again, we're just going to insert everything into the distance formula. So we have d is equal to the square root of -3 minus -1 squared plus 2 minus -4 squared. Okay, and excuse me, we just have to work this out. So let's try to simplify what's inside of the radical. Namely, let's take care of the -3 minus -1 and 2 minus -4, and then we can square the values. So if you look at 3 minus -1, you can rewrite that, right? 3 minus -1 is the same thing as saying what?
-3 plus 1.
That's right. It's -3 plus 1. And what is -3 plus 1?
-2.
That's right. -2. So we're going to have -2 squared. If you look at the other expression, 2 minus -4, you can also rewrite it. It's going to be what? 2 plus 4. And what is 2 plus 4? 6. So we have -2 squared plus 6 to the second power. All right. Now, what is -2 squared followed by -2 squared followed by 6 squared? Yes. 4 plus 36. Okay, and what is 4 plus 36? 40. So we get that d should be equal to the square root of 40. Although this is a good answer, the question states that if necessary, express the final answer in simplified radical form. So when you look at square root of 40, is there a factor of 40 that's a perfect square for us that will allow us to break this square root of 40 down further? Is there a factor of 40 that allows me to simplify the radical any further? Think of your factors of 40. Let's list them. Can somebody give me any factors of 40? Any factors that you know of?
2,
2. Yeah, 2 definitely goes into 40. How many times does 2 go
5.
into 40?
5.
No, 2 doesn't go into 45 times. Say louder.
No. 20.
20, yes. Now, don't get me wrong, 5 also goes into 40. 5 goes into 40 how many times?
8.
8. Is there any other pair that we can think of? Yeah, 1 and 40. Is there another pair? 4 and 10. So other than the number 1, look at the other factors of 40. Are any of them perfect squares? Yeah, which one? The 4. So the square root of 40, we can break it down as the square root of 4 times the square root of 10. Now, what is the square root of 4? Yeah, square root of 4 is 2. So we're going to get 2 square root 10. And because 10 is not a perfect square, and none of its factors are going to be a perfect square, namely 2, those factors are 2 and 5, then this will be your final answer. 2 square root of 10. Oops, meant to put a box like that. There we go. And that is your solution. Is there any questions to problem number 1? Most stacking. I hope I sorry, I probably oh, okay, no questions there. Saw your hand up, that's why. Anybody else? Any questions? Is it okay for us to move on? Alrighty, so we're going to continue. We're going to go on to problem number 2. Okay, so in problem number 2, it states write the standard form of the equation of the circle with the following characteristics. We have that the center of our circle is -3, 5, and the radius is 3. So, anybody know the standard form of the equation of the circle, or in short, do you know what the equation of the circle is? Mm-hmm. That's right. So we have that the formula, I'm just going to write it in the reverse. It's x minus h squared plus y minus k squared is equal to r squared. What do we know about h and k? What does the hk represent? Or the values of h and k? Yeah, go for it.
It represents the circle center.
Yes, it will be the center point. So the center point is denoted as the ordered pair h comma k. And we also know that, well, r stands for what? The radius. Okay, so in this problem, the center point was given to us, -3, 5, and the value of r is also given, right? So the center point -3, you can label that as your h, and the 5, the y coordinate, you can label it as k, and you substitute everything now into your formula, right? So just substituting, we're going to get x minus -3 squared plus y minus 5 squared is equal to the value of r, which is 3 squared, right? So we have everything substituted into the formula. Now we can go ahead and simplify, right? So we substitute. Now simplify. So x minus negative 3, can we simplify that just a tad bit? Anyone? How can I simplify x minus negative 3?
Is that x plus 3 squared?
That's right. That's going to be x plus 3 squared plus y minus 5. You can leave it alone, right? So anytime that you have that there's two negatives next to each other, convert the two negatives to a positive, just like what we did with the x minus negative 3. On the other hand, with y minus 5, you can leave it alone. So it's y minus 5 squared equals to the value of r raised to the second power. Do we know what's 3 to the second power going to be? 9. That's right. So x plus 3 squared plus y minus 5 squared is equal to 9. That's essentially the equation of our circle. Right. So when you're going to be solving this problem, let's say on Pearson MyLab, for example, please make sure that after you do the substitution, you just simplify a tad bit, but where you take the value of r, you square it. And for your center point, you just make sure that if there's two negatives next to each other, convert the two negatives to a positive. Sounds good? If you have any questions, let me know. All right, let's look at problem number 3. Problem number 3, we're going backwards now. Problem 3 states, give the center and the radius of the circle described by its equation. X plus 4 squared plus y plus 5 squared is equal to 36. So again, this problem is essentially problem number 2, but we're going backwards, right? We know that the equation of the circle is defined as x minus h squared plus y minus k squared is equal to the value of r raised to the second power. So what we need to do here is find the center, right? The center is denoted again as the order pair, h comma k, and the radius, the value of r, okay? So looking at the given equation versus our formula, can you sort of do some sort of rewrite so that way you can determine their center point and your radius? Yes, you can. You could do some sort of rewrite. Abuka, right? No. Abu. Sorry, Abu. Abu, what's the, how can I rewrite this? Yes. Yes. That's right. Essentially, from the x plus 4, you can factor out, instead of writing it as plus 4, you factor out a negative 1, right? So you say if you factor out a negative 1 from that plus 4, it's x minus negative 4. Okay, good. X minus negative 4 squared plus, okay, y minus k squared. Well, if the equation is y plus 5, how can I rewrite that so it mimics our formula? Yeah, you could do the same thing. What would it be? Careful. There you go. Y minus -5 squared equals, well, 36 is equal to our R squared. Can you rewrite 36 so that way we could identify the value of R? Yeah. 36 is a perfect square number, right? So what is the square root of 36? 6. So R squared, which is equal to 36, right? I'm just going to do this on the side here. 36 is equal to R squared. This implies that 6 is equal to R. Okay, so now you can go ahead and give your center. And you can also give your radius. So the center point is now going to be what, Abu? -4, -5. And the radius, well, it's just going to be 6. Right? And that's it. You was essentially going backwards. From the equation of the circle that's given to you, you have to find your center and you have to find the radius. It's important to note that when you look at the given equation versus your formula, you do some sort of rewrite if necessary. Namely, if you look at that +4 or that +5, you're just doing a slight rewrite so that way you could be able to identify the coordinates for your center point. Alrighty. Is there any questions to problem number 3? I see a hand up in the
I have a question.
Yes, Mahmoud.
Wait, how did you get the -5 and -4? Because if we negative 4 square, which would be +16, isn't it?
Well, the thing is, you got to be a little careful here. We're not actually squaring the -4, right? In particular, if I were to square -4, it's still the same thing as squaring a +4. The issue is, well, let me just clarify something real quick. So this is just on the side here. If you look at x plus 4 squared, this is not equal to x squared plus 4 squared, right? Unless that the x is equal to 0, then this would have worked. This would have been a true statement. But if x is not equal to 0, then unfortunately, no, you just can't distribute this square, this particular square, inside the parentheses because it's a sum of multiple terms. Namely, it's a binomial. If you wanted to actually compute x plus 4 squared, it's the same thing as saying the binomial, the x plus 4, is being multiplied by itself. And here you would have just used the process of foiling, okay? We're going to talk about foiling a little later on when we look at evaluating functions. But I just want you to just make a note that x plus 4 squared is not necessarily the same as saying x squared plus 4 squared. Now, how did I get the -4 and the -5? Well, look at just the +4 again. +4 is the same thing as saying -1 times -4. And you can rewrite this without the 1 that comes after the first negative sign. You can say that this is just equal to negative of -4, okay? So when I look at the given equation versus our formula, we're rewriting the given equation, if necessary, to mimic that formula. And that's how you will get the precise coordinates of your center. You're welcome, Mahmoud. Anybody else? Any other questions? Somebody has their hand up. Yeah, Christopher, go ahead.
So my question in regards to this problem is that this will be like the problem that will be applicable towards like finding the radius and the center, right?
That's right. That's what the question asks.
So so basically you just squared everything just to cancel out the squared.
Not quite. I didn't square everything.
Okay.
That's what Mahmoud was asking a little earlier in one of his questions. No, we're not squaring everything. I'm doing some sort of rewrite. For example, the positive 4, I rewrote it as negative of -4 from the given equation. And the same thing with the positive 5. You rewrite it as negative, you rewrite the positive 5 as, my bad, as negative of -5. The only thing that you're actually doing some sort of, well, not really squaring, but you're actually taking the square root. Since 36 is equal to the r squared, then when you take the square root of both sides, you're going to get that 6 is equal to r. Okay. So I did not square anything. All I did was I rewrote my equation to mimic our formula, the one that I have the arrow pointing to. And for the radius, to find it, I take the value of r squared and take the square root of it. Okay.
Yeah. The only reason what led me to that question was based off like the formula that's given. I see like the step 3 of the formula is like negative, like both.
Yeah. So any time inside of the parentheses you have something that's positive, you're factoring out a -1, right? You're factoring out a negative. So the number that was originally there, like the positive 4, positive 5, will now become a -4 and a -5.
So correct me if I'm wrong, but essentially you're saying that in order to be able to solve this problem is that
you have to rewrite it.
You have to, yeah, basically not only rewrite it, but factorize.
Yes, in a sense, yes. You're just factoring out a -1 from the positive 4 and from the positive 5. That's it. You're not doing any other factoring, or you're not applying any other factoring techniques.
Okay, thank you so much.
You're welcome. Anybody else? Okay, so this was the first part of our review session. We covered the distance formula and we covered circles. Now we're going to move into lines. So we're going to cover the majority of, or pretty much all the type of problems you're expected to solve regarding lines, namely finding its slope, writing the equation of the lines in something called the point slope form and slope-intercept form. We're also going to look at graphing lines using the slope-intercept form. And we're going to find parallel perpendicular lines, and along with writing the equation of the line given its graph. Okay, so the second part is a little lengthy. All right, so here goes. Problem number 4 states, write an equation for the line in point slope form and slope-intercept form if the line is passing through a pair of points. So we have -2, -5, -2, -5, and 6, -5. So for problem 4, again, we're going to need to know 3 things here. First of all, if you're given a pair of points, you need to know how to compute the slope m. Anybody know the formula for your slope? How do I find the value of m? Yeah? No.
So wouldn't it be y2 minus y1 over x2 minus x1?
That's right. So your slope is the change in y, y2 minus y1 over x2 minus x1. That's the first thing that we're going to need to know. The second thing that we're going to need to know is our point slope form. What is the equation of the line in point slope form?
Y equals mx plus b.
Unfortunately, no, that's the slope-intercept form. So that would be formula 3. So I'll write it out since you mentioned it. So we have slope-intercept form, which is y equals mx plus b. But let's go back. We got to figure out what's the point slope form. We're going to be using these two particular forms for a bit of for almost all the problems. So go ahead.
Pardon me, but wouldn't it be parentheses y2 minus y1 equals m plus mx, that's an mx, time plus equals m parentheses x2 minus x1?
You're close. The thing is, when you're looking at the point slope form, all you really need is just a 1 point. You need 1 point and you will need your slope. So the x and y, they could be arbitrary points that lies on that line. So with that all being said, instead of saying y2 and x2, you can replace that with the values of just y and x. You say y minus y1 is equal to m times x minus x1, right? X1 and y1 is a specific point that belongs to the line. M, of course, is your slope, but x comma y can be any point that lies on the line. All right? Okay, so there are the 3 formulas that we're going to use to solve problem 4. So it's a 3-step process. First, you find the slope. And the way that we find our slope m is by labeling our points and substituting them into our formula. So we have x1, y1, x2, y2. And you just plug it into your formula. So we say m is equal to the change in y. So it's -5 minus -5 over 6 minus -2. And we just simplify. Anybody know what's -5 minus -5?
0.
Yeah, that's going to be 0. One way of showing it as 0 is saying that we have, well, -5 plus 5. So that would give us 0 on the top. What about the bottom? What is 6 minus -2? 8, right? Because you can rewrite the bottom as 6 plus 2. All right, so what's 0 divided by 8?
Isn't it undefined?
Unfortunately, no, it's not undefined. It's only undefined if we had any other number on the top and then the 0 on the bottom. You can have any number on the top but 0, but if you have 0 on the bottom, then it's undefined. But 0 over 8, if you're dividing any number into 0, if 0 is on the top essentially, then the answer is 0. There you go. So we have that m is equal to 0. Now, before I do the next 2 parts, if m is equal to 0, do anybody know what type of line I'm dealing with here? There's a specific line that we deal with when m is equal to 0.
A horizontal line?
Very good. When m is equal to 0, this implies that we're dealing with a horizontal line. So note, horizontal lines have a slope of 0, right? We call them the constant lines because there's essentially there's no rise, there's no run. Everything is just constant. Okay. Now, in general, when you deal with horizontal lines, the equation for horizontal lines is always this form of y equals b. Now, I don't know how MyLab proceeds with this. So I'm going to show you how to do the point slope form, and then from there, show you how to get the slope intercept form. If you want to find now your point slope form, right? Sorry, I'm going to write point slope form here. So I can save some room. All I need to do is just plug in one of the points and one of the given points and the value of m into our formula. Now, just keep in mind that you can use any one of your 2 points. You could use -2 comma -5, or you could have used 6 -5. I'm going to use 6 comma -5. On your own, you can do -2 comma -5. It's up to you, but again, I'm just using the second point. So using 6 comma -5 and m equals 0, we have the following. We're going to get y minus the value of our y coordinate, -5, is equal to the value of our slope, 0, times x minus 6. Now, this is a good answer for your point slope form. But again, if you're doing this on MyLab, you might have to simplify this just a tad bit. Can we simplify this just a tad bit here? In other words, is there any way for me to simplify one side of the equation?
Yes.
The left side, that's right. If you look at y minus -5, you can rewrite that as what?
Y plus 5.
Yeah, you can rewrite it as y plus 5. And the other side, you can leave it alone. So don't quote me on this, but I think this equation of the line in point slope form is simplified enough, and that would have been one of your solutions, right? I don't think on MyLab you go any further with this for the point slope form, okay? Just make sure that if there are 2 negatives next to each other, combine them to form a positive, just like what we did with the y minus -5. Is there any questions with the point slope form before I move on to the final step?
I do have a question.
Yeah.
So you see where we have m as defined as 0.
Mm-hmm.
I was thinking like, even though we didn't do it here, do we have to distribute the 0 if it's like
In the
not
next step.
m?
In the next step.
Okay, pardon me.
It's all good. You have to write
Yeah.
the equation first in point slope form, where you can where you basically plug in the point, your order pair and the slope, and just do a little simplifying by combining any 2 negatives as possible. In the last step now, when you write the equation in slope-intercept form, namely y equals mx plus b, you're going to use where we left off with, take that equation, y plus 5 equals 0 times x minus 6, and you rewrite the equation where y is isolated by itself, right? So this is where you start distributing. If you look at the right-hand side of the equation, if I take the number 0, multiply it by x and -6, what do we get? 0. So this is going to be y plus 5 is equal to 0. And if I want to solve for y, what do I have to do on both sides of the equation? Subtract 5. So if I subtract 5 on both sides, this equation now becomes y equals -5. And that's your equation now in slope-intercept form. Again, you're probably wondering what happened to the mx, right? Putting that in quotes. Just remember, the slope was 0. Anytime that you have a slope of 0, you're dealing with a horizontal line, and its equation is in the form of y equals b. Anybody know what does the b stand for, by the way?
Y-intercept.
Right. B is called the y-intercept, right? So if my y-intercept is going to be -5, then I know that my line is going to be a constant line where the line has to go through that ordered pair. So I'm just going to zoom in just so I could draw the small visual of this. Let's say here's the y-axis. Let's say here's my x-axis. You could plot the order pair 0, negative 5. So let's just assume for demonstration purposes, that order pair is 0, negative 5. And you draw a horizontal line that just goes through it. Just like the one shown in red. So that line in red is y equals negative 5. Right? M in this problem was 0. Okay. Is there any questions? Any questions to problem 4? All right, like I mentioned, I want to go through almost all the type of questions that you can see regarding lines. So let's look at problem number 5 now. Problem number 5 is where you actually have to graph the line. And if you're graphing a line that's not a horizontal line or not even a vertical line, by the way, vertical lines have an undefined slope. One thing that you need is 2 points. And the way that you can get 2 points based off a linear equation is finding its x and y intercept. Okay, so I'll show that in the next example, how to find the x and y intercept, how to rewrite a linear equation in slope-intercept form, and I'll show you what the graph looks like. So problem 5 states, given the linear equation, 4x plus 6y plus 12 is equal to 0. Find the x-intercept, the y-intercept, and the slope, then use this information to sketch the graph of the linear equation. Essence, I'm sorry, I just saw your question popped up in the chat. My bad. Are you talking about Professor Tanya for MAT171?
No, it's the guy. I think his name is Raphael.
Oh, Rafael Gonzalez. Essentially, yeah. I'm going over. I have some of those questions inside of my review, and I have other. It's basically a variation of questions. So some of the questions that I'm doing here should be on your first exam. And I'm going over also additional questions. You probably won't see those questions on your first exam, but you probably see it later on for the final, right? So for example, I'm just going to scroll all the way back to the beginning. Again, I'm covering these 3 topics, which should be on the first exam. Most of the problems that I have here should be related to it. However, there are probably some that are not. And if it's not there, then it definitely will be on the final. Right, especially the ones I highlight in yellow.
Oh, okay, because I just had some questions about the work that he gave us to review.
Okay, sure. So when I get to those questions, just please let me know, okay?
Okay, thanks.
I don't have his questions numbered or ordered the way that he did. So if you see that the question resembles something from the review, just from your personal review, just let me know.
All right.
Okay, cool. So here's problem number 5. Given the linear equation, 4x plus 6y plus 12 is equal to 0, we had to again find the x and y intercepts. Find the x-intercept, the y-intercept, and your slope, then use this information to sketch the graph of a linear equation. So algebraically, there's a way for us to find the x and y intercepts. How do we find, let's say, the x-intercept? What can I do algebraically?
Put y as 0.
That's right. To find the x-intercept, set y is equal to 0, and solve for x. All right, you're solving for the other variable, namely x. Okay, now how do we find the y-intercept? That's right. To find the y-intercept, you do the reverse. Set x equal to 0 and solve for y. So let's take care of that. Let's find both the x and y intercepts. Then we'll talk about the slope in the third step. And then after that, we can graph. So for our x-intercept, again, just following what you guys have mentioned so far, we're going to set y in the given equation, 4x plus 6y plus 12 equals to 0, and solve for x, right? So we're replacing that y with 0 and solve for x. So what is 6 times 0? 6 times 0 is going to be 0, so that's just going to go away. We're going to have 4x plus 12 is equal to 0. Now we got to get x by itself. How do I get x by itself here?
Subtract 12.
That's right. Subtract 12 on both sides. So this will give us 4x is equal to negative 12. Then you divide by 4 on both sides. That's right. So if we divide 4 on both sides, the 4's on the left will cancel. You're going to get x equals negative 12 over 4. What's negative 12 divided by 4? Negative 3. Now, just a heads up, because we're going to be dealing with the graphing a linear equation, we got to make sure we write out these x-intercepts and the y-intercept as ordered pairs. So if the x-intercept is negative 3, as an ordered pair, what would that be?
Negative 3, comma 0.
There you go. Negative 3, comma 0. That's your x-intercept. And now we move on to the next step. Well, we got to get the y-intercept. To get the y-intercept, we replace x with 0, solve for y. So this is 4 times 0 plus 6y is equal to, plus 12 is equal to 0. Okay, what's 4 times 0? 0. We're going to have 6y plus 12 is equal to 0. Now we solve for y. What do I do here? Subtract 12 on both sides. This will give us 6y is equal to negative 12. And then divide 6 on both sides. So if I divide 6 on both sides, y is going to equal to what value? Negative 2. Right, you get negative 12 over 6, which is negative 2. And now you write out the y-intercept as an ordered pair. So what would the ordered pair be?
0, negative 2.
Yeah, 0, negative 2. All right, so we have both the x and y intercepts. Now we got to talk about our slope m. Well, look at this equation. 4x plus 6y plus 12 is equal to 0. Is that equation in slope-intercept form? No, it's not in slope-intercept form. So based on the way that the equation is being presented, I can't identify the slope, not at the moment. However, we can. If I look at, I'm just writing out the equation again, 4x plus 6y plus 12 equals to 0. If I want to determine my slope, what do I do with this equation?
Do we plug in our y-intercept for this equation?
Unfortunately, no.
Meaning like negative 2 at
Nope.
y.
Unfortunately, no.
Oh.
If this is our given equation of the line, and I want to identify my slope, right? Remember, what is the slope-intercept form? What is the slope-intercept? Yeah, it's y equals mx plus b. So what you're going to need to do is take that given equation and rewrite it in terms of y equals mx plus b. The only way that you can rewrite it in terms of y equals mx plus b is by solving for y, okay? careful. Let me write it out first and then we'll do it. So from this given equation, rewrite in terms of y. Okay, so if you want to rewrite this equation in terms of y, we're basically pushing everything else to the other side of the equation. So looking at our given equation, what can I move to the other side? We can move the 12. How can I show that algebraically? That's right. You're going to subtract 12 on both sides. So if I subtract 12 on both sides, 12's on the left are canceled. This will be 4x plus 6y is equal to negative 12. What's next? Subtract 4x on both sides. So the 4x here will cancel. This will give us 6y is equal to negative 4x minus 12. And what's next?
Divide by 6.
Divide by 6 on both sides. Now, be careful when you're going to divide 6 on both sides, just make sure that you're dividing every other term on that right-hand side by 6. So the 6 on the left will cancel. That will give you y. What's negative 4 over 6? Can I reduce that a little bit? Yeah, that's going to be what? Yeah, negative 2/3. So it's negative 2 over 3x. Then negative 12 over 6. Can I simplify that just a tad bit? Yeah, that's going to be what? Negative 2. Okay, so when you look at this equation now, y equals negative 2/3 x minus 2, you're capable of finding two things, namely your slope. All right, our slope here, m, is going to equal to what value?
Negative 2/3.
M is equal to negative 2/3. Now, with the slope being negative 2/3, what does that imply about the line? Will the line be increasing or decreasing? It's decreasing. So I'm just going to put this in quotes. We should draw a line that's essentially decreasing. And another thing that you got from this equation was the y-intercept, right? The value of b. B was equal to what number? Negative 2. That correlates to what we did algebraically, right? We found the y-intercept algebraically, but again, if you rewrite the equation in y equals mx plus b form, you will identify m and b, both values, m and b. Okay, so we have everything that we needed. Now we make our sketch. So I'll do my sketch here in this bottom right. Here's my y-axis. Here's my x-axis. Now I'm not going to do this in a perfect scale. I'm just going to estimate where these points are. So let's say somewhere around here is your x-intercept. I'll bold it in with that point there. That's going to be negative 3, 0. And let's just assume that somewhere here is the y-intercept, 0, negative 2. And you just got to draw a line now that goes through those points. Namely, you'll see that the line is decreasing. And there you go. That would be the equation of our line. Any questions? There was a lot that we did in this problem, so if you have a question, I could entertain it. Oh, somebody has their hand up. Go ahead. I'm sorry. Christopher, go ahead.
My question was that, like, can we use like the points that we got from y-intercept and x-intercept to check to see if like the slope?
Wait. Say that one more time for me, please.
I said, can we use the y-intercept and the x-intercept to figure out if like the the points that we got from those formulas is applicable to like the slope?
Like intercept? Yeah,
form?
you definitely can. If you plug in those order pairs into the equation that I'm putting a box around, oh, sorry. If you plug in both those order pairs in there, you'll get a true statement. You're going to get a true equation. Like, for example, with the y-intercept, all you got to do is replace the x with 0, y with -2, and you will eventually see that -2 is equal to -2. Similarly, if you take the x-intercept, its coordinates, -3, 0, replace them for x and y, what you're going to get is 0 is equal to 0. Although I'm not showing it I'm not showing it on screen. I'm hoping that you followed along. But yes, to answer your question, yes. Can you locate M in the graph you sketch? You can, Mahmoud. You can use the geometrical representation of slope. You can use the idea of rise over run. Technically speaking, our rise is not going to be essentially a rise at all, right? Because if you look at your x coordinates for your rise, quote unquote, you're doing -3 minus 0. Sorry, you're doing for the rise part, my apologies. You're doing sorry about this. You will be doing -2 minus 0. And then for your run, you're going to have to do 0 minus -3. So that was the rise, and that's your run. So the rise would have been -2, the run would have been 3. And if you put it together, you get -2/3. So yes, you can locate M geometrically by interpreting slope as rise over run. But I don't have to do it in that manner as long as I have the equation in slope-intercept form, because once I know that the slope is negative, the line should be decreasing. If the slope is positive, you should know that the line is increasing. Are we okay to move on? You're welcome, Mahmoud. Okay, so as I mentioned, I forgot about this. So I forgot about this during my last review, and I forgot about it here. Problem number 6, which is on your final exam. I don't know about your first exam, but it's definitely there on the final because it's highlighted in yellow. It states to write the equation of the line in slope-intercept form based on the given graph. Well, unfortunately, the given graph ain't there, so I have to draw one, which is fine. The thing is that when you look at your given line, all you need is 2 order pairs. One of the main order pair that you want to look for is a y-intercept, okay? So let's just say, I don't know, I'm just going to make something up. Let's say that one of our order pair is -3, -4. And let's just say that the other order pair is 0, 2. Let me just use my ruler here. You can tell automatically that if I was a barber, I would have lost my license. Probably got punched in the face a couple of times. Say it again? That's right. All right, so let's say this is our line. And we know that you have these 2 order pairs, 0, 2, and 3, -4 that goes through those points, right? I made the whole line, and I made up those order pairs. We want to write the equation of the line in slope-intercept form. And we already established slope-intercept form as y equals mx plus b, where m is your slope and b is your y-intercept. So because you're given 2 order pairs, sometimes you have to find them, but usually you have to find them, but I'm giving them to you here. You have to figure out what's your slope? So you use the slope formula, right? The change in y over change in x, right? First, find m. Okay, so m is equal to, again, y2 minus y1 over x2 minus x1. Change in y over the change in x. So you label your points. So let's say this is x1, y1, x2, y2, and you insert it into your formula. So you're going to get -4 minus 2 over -3 minus 0. Okay, let's work this out. What is -4 minus 2? Negative? Yes. -4 minus 2 is the same thing as saying -4 plus -2. So yes, -6. And -3 minus 0? -3. So what's -6 divided by -3?
2.
It's equal to 2. And by the way, if m is equal to 2, will our line be increasing or decreasing? Increasing, yeah. Anytime the slope is positive, the line should be increasing. So we have that m is equal to 2. Okay, now determine the value of b. Well, remember, b stands for your y-intercept. Was the y-intercept given to us here? Yes, it was. I said that at the beginning, that in these type of problems, you want to look for if the y-intercept is given. If it is, we can use it. The value of b here is going to be what? 2. Well, I know what's the value of m. I know what's the value of b. Just substitute into your formula, right? So the equation of the line, y equals mx plus b, is now going to be y equals 2x plus 2. And
I
ta-da,
have a
you're
question.
finished. Yeah, go ahead.
Could we also say that y equal -4?
Whoa. Y is equal to -4. Why do you want to say that?
Because the second point where the x2 is -3 and y2 is -4.
That's right.
So you could assume that -4 could be a y value.
Yeah, that is true. You're writing out the equation of the line in slope-intercept form where the x and y are arbitrary points that lies on the line. So y doesn't always, have to be -4. Y could have been a value like, I don't know, it could have been 0. It could have been an x-intercept that we would have had to find algebraically, which isn't that bad. That would have been -1, 0, that order pair, right? So technically speaking, there's this order pair here that's -1, 0, because if you plug -1 into the equation, 2 times -1 is -2, -2 plus 2 is 0. So long story short, x, y is any point that lies on the line. Okay, so if you were to write -4 equals 2 times the value of x2, which is -3 plus 2, unfortunately, you would have been wrong because that's just one solution. You need to write out the general solution of the in slope-intercept form, which basically contains all the solutions, and you'll have the value of m. More importantly, you just need to figure out what's the value of m and b and substitute into your formula. Sounds good?
Yes.
All right, let's look on to problem number 7 now. So this is one of the problems, again, that I said was going to be on your final, not necessarily your first exam, but who knows? That's why I have it here. Problem number 7 now, there's 2 parts where we're just going to need to know 2 definitions. So it states, use the given conditions to write an equation for each line in both point slope form and slope intercept form. So if we want to talk about the conditions, part A states that the line is passing through the order pair -1, 6, and is parallel to the line 2x plus 5y equals 8. In part B, it states that the line is passing through the order pair -3, 2, and is perpendicular to the line y equals 1/3 x plus 7. Okay, so we need a couple of definitions. We need to know what it means for two lines, we'll call them L1 and L2, to be parallel, and what it means for both of those lines, L1 and L2, to be perpendicular. So if two lines, L1 and L2, are parallel, then what do we know about those lines? What is a characteristic, or what is something that we should know about two lines that are parallel?
Their slopes are like the inverse of each other or something like that?
Not quite. Not in the case of parallel. Got to be careful how you use the word inverse as well. Go for it, Abu. What do you say? They will what? That's right. The two lines will never intersect, right? And why is it that they never intersect? What do we know? Namely, what do we know about their slopes?
They're the same?
They're the same. That's right, Emily. If two lines, L1 and L2, are parallel, then M1 is equal to M2. Their slopes are the same, right? Same slope. But of course, they have a different y-intercept. Okay, let's look at the second definition. If two lines, L1 and L2, are perpendicular now, then what do we know about, let's say, their slopes? Well, we can't define perpendicular with perpendicular. They're reciprocal. So I think it was Emily that mentioned it. Emily, you used the word inverse. You got to be a little bit careful on that.
Yeah, that's what I meant.
You meant the reciprocal, meaning informally just a flip, right? One slope is the flip of the other, but there's something else, right? Let's say that I wrote that M1 is equal to 1 over M2. What's technically missing? Excuse me. Not a y-intercept. They are, M1 and M2 are reciprocals of each other, but what type of reciprocals? What's missing? A negative reciprocal. There you go. So you put a negative sign in front of that, in front of the 1 over M2, right? So we say that they're negative reciprocals. All right, so this problem, the way, again, we have to do both point slope form and slope intercept form. We already know what those forms are. For both problems, one problem has an additional step than the other. And I will identify that when we do both of them. So let's look at part A. Part A, we have the following information. We had a given point. So I'm just going to rewrite some of the stuff so I don't have to keep going back and forth. The given point was -1, 6. The given line, by the way, you call that your L1. That's the first line, was 2x plus 5y is equal to 8. And what we're trying to do is find line 2 given that L1 and L2 are parallel. Okay, so again, using our definition, we know that two lines are parallel if they have the same slope. Well, since the given line was, we call that L1, which was 2x plus 5y is equal to 8. Based on the way that equation is written, that linear equation, do I know what the slope is? Based on the way that that line is being presented. Can you tell, for example, can you tell right off the bat what the slope of that line is? No, you cannot, because the equation is not in slope-intercept form. So first thing that you want to do is figure out the value of M1 and find the value of M2. But before that, before you can even get M1, you got to rewrite your given line, namely line 1 in y equals mx plus b form. Right, so step 1, determine the value of M1 if necessary, rewrite L1 in y equals mx plus b form. So here's the case where you have to rewrite the given line, L1, in y equals mx plus b form. So the equation was 2x plus 5y is equal to 8. How do I rewrite this equation in terms of y? That's right, subtract 2x on both sides. So this will give us 5y equals negative 2x plus 8. Okay, what's next? Divide 5 on both sides. Now just remember that when you divide 5 on that right-hand side, you're dividing all the terms by 5. So the 5's on the left were canceled. You're going to get y equals negative 2 over 5x. By the way, can negative 2 over 5 be reduced any further? No, that fraction cannot be reduced any further. So we have negative 2 over 5x plus 8 over 5, which also cannot be reduced any further. Okay, can you figure out what's the value of M1? That's right. M1 is equal to negative 2 over 5. So once you determine the value of M1, you can also, so I'll put this in step 1 as well because I'm running out of, I want to save the rest of the space for the rest of the problem. You could also identify M2. So if M1 is negative 2 over 5, then what does that imply about the value of M2? It's also going to be negative 2 over 5 because the two lines have the same slope, right? It was given that line 1 and line 2 are parallel. Is there any questions to step number 1? I see a hand up in the chat. I don't know if you had a question. I think that was Christopher.
So it doesn't matter if like the b is a fraction, right? Like because we're not using the graph.
No, it doesn't. It doesn't matter if b is a fraction. If you can reduce the fraction, you can. But typically you leave it in fraction form.
And plus,
okay.
In regards to the fraction,
you have to speak a little louder. You're not speaking into your mic.
In regards to the fractions, once again, if that's like, are we gonna always need to put the fractions in simplest form, or can we just leave fractions as they are?
I think you should put it in simplest form. Like if you can reduce the slope, then definitely reduce it. If it can't be reduced any further, then leave it the way it is. One of the things, I don't know if you're going to be one of the students that will be taking the exam on my lab, but my lab has specific instructions. That's why I'm taking my time going through these problems. So that's why I mentioned that if your slope can be simplified, definitely simplify it because my lab might mark it wrong. Sounds good?
Thank you. Yes.
You're welcome. Okay, so we got step 1 done. Now we get steps 2 and 3 done. Step number 2 is now going to be the point slope form. For the point slope form, you're going to use the given value of M2. In fact, you could use the value of M1 here because the lines are parallel, same slope. But more importantly, for the second step, just remember that you're going to be using M2. So using M2 is equal to -2/5. And the given order pair, -1, 6, we have the following. It's going to be y minus the value of y1, which is 6, equals our slope, -2/5, in parentheses, x minus -1. Now, on my lab again, it's going to ask you to simplify this. Can I simplify my point slope form just a tad bit? Yeah, how can I rewrite this or just simplify it? Just a little tad of simplifying. Yes, that's right. The x minus -1 will become x plus 1. So for the steps 2 final answer, you will enter y minus 6 equals -2/5 times x plus 1. And there you go. Now you go on to step number 3. Step number 3 is where you use the rewrite step 2 as y equals mx plus b. So you have to rewrite the equation in terms of y, namely the slope-intercept form. So now here's where you continue working on the arithmetic. We pick up from where we left off. Y minus 6 equals -2/5 of x plus 1. We're going to distribute the -2/5 inside the parentheses. So we get y minus 6 equals -2/5x minus 2/5. Since -2/5 times 1 is just going to be -2/5. And now we add 6 to both sides of the equation. So this is how I usually solve this when I have fractions. I'll write it this way. I write it horizontally. I say y is equal to -2/5 x minus 2/5 plus 6. Now, can I add 6 to the -2/5 based on the way it's being presented? No. What do I have to do to the 6 first?
Put it over 1.
Yeah, write it as a fraction where we divide it by 1. And we find something called the LCD, right? You have to have like denominators. So if you look at your 2 denominators there, it's 5 and 1. What do you think is your like denominator, your LCD? LCD is 5, right? So I'm just going to write that on the side here. LCD is 5. So we already have the -2/5 having a denominator of 5, so there's no rewrite there. If I change the denominator of 6/1 to a 5, then just remember I have to also change the top. So what number times 1 gives me 5?
30.
No, well, yes, for the top, yes, it's going to be 30. But the only way you got 30 is because of the fact that 1 times 5 was 5. And if you do the same thing on the top, 6 times 5, you're going to get 30. Okay? So I'm going to cross that out now. Okay, so reading our answer now, we're going to get y equals -2/5x. What's -2/5 plus 30/5?
28/5.
That's right. You're going to get positive 28/5. And that's your final answer. Okay, so there was 2 answers. The point slope form was one of them. It was one of the intermediate answers where you had to write your equation in point slope form, simplify if necessary. Step 3 is where you write your equation of the line in y equals mx plus b form. Sounds good? Okay, let's look at 7b now. I think after we do 7b, we're going to go into, we're going to look more into functions, right? So 7b is the last part for talking about lines. But all the type of questions that we went over today for lines, that's a very good foundation for your exam 1 and including the final, okay? So here's 7b. The given point was negative 3, 2. We have that the given line, again, we call that our line 1. It was equal to y equals 1/3 of x plus 7. And we also know that line 1 is perpendicular to line 2, and we have to find what line 2 is. So we're going to apply the same 3 steps that I mentioned here in part A. Determine the values of your slopes, then figure out the point slope form, and then the slope intercept form. So from step number 1 of our previous step, it says determine the values of M1 and M2, and if necessary, rewrite the given line 1 as y equals mx plus b form. Well, looking at this equation of line 1, y equals 1/3 x plus 7, is it in y equals mx plus b form? Yeah. Yes, it is. And because it's already in y equals mx plus b form, you should be able to establish what's the value of m, right? So L1, again, was y equals 1/3 of x plus 7. So M1, the slope of this line is going to be what? 1/3. Now, since line 1 is perpendicular to line 2, what do you think the value of M2 is going to be?
-3.
Yeah, you take the reciprocal, 1/3 reciprocal is 3/1, and you negate that value. So it's -3/1, which is -3. And that's it. Step 1 was done. So now we move on to step 2. After you establish the your value of M2, use that value and the given point to write the equation in point slope form, right? So using M2 is equal to -3, and you have the order pair -3, 2, we have the following. We're going to get y minus the value of y1, which is 2, equals the value of your you're going to have the value of M2 for your slope, which is -3, times x minus -3. Can I simplify the point slope form just a tad bit? Yeah. Which part am I simplifying? The left-hand side or that right-hand side?
Right-hand side.
The right-hand side. Namely, we're combining the two negatives. So this will become y minus 2 equals -3 times x plus 3. So that's your point slope form. All right, now we move on to step number 3. The final step is to write that, to pick up from where you left off and write it in terms of y equals mx plus b, right? So basically rewrite in terms of y. That's what we're doing algebraically. So we pick up from where we left off, y minus 2 equals -3 times x plus 3. You're going to distribute the -3 inside the parentheses first. This will give us negative 3x minus 9. Then you add 2 to both sides. So the 2's on the left are canceled. This will give us y equals negative 3x. What's negative 9 plus 2? Negative 7. And that's it. This would have been now your slope-intercept form. Ta-da, done. Any questions?
I do have a question.
Go ahead.
For step 1, right? How did you get negative 3?
Oh,
wait, never.
The lines are perpendicular, so their slopes are negative reciprocals. Just going back to this definition. What I'll do is I'm about to just take a sip of my juice here. Let's see. No. What happened? Zoom. Oh, sorry. I clicked the wrong thing. Let's see. Can I rotate this real quick? I'm just gonna rotate this. Hopefully you guys can see both of them. Wait, let me ask you guys this question. With my screen rotated vertically the way it is right now, can you guys see the both 7A and 7B?
Yes.
Yes.
Okay, I'm gonna leave it like this for now. Just note that when I'm gonna solve some problems, I'll zoom in just so that way I could save space. Okay, because when I have it in this particular format, I just can't fit everything. It makes it write a little bigger. That's why. So I'll zoom in when necessary. But I'm gonna leave it like this for now. I'm just grab a sip of my juice. All right, I'm good. Okay, any other questions? Okay, so we've done the first 2 parts of our review. We went over the distance formula and circles. We did lines, slope, equations, and graphs. Now we're going to talk about functions. We're going to look at this algebra first, then we'll look at limited domains, and we'll wrap it up by graphing functions by sketching. So depending on your pre-calculus instructor, they, on their first exam, they might have just the algebra part. Some might do algebra and limited domains, and some might do all 3. So just be mindful that, again, if it's not on your first exam, then the problems that I'll show you, some of them will definitely be on the final or possibly your second exam. So here's problem number 8. It says, give the domain and the range for each relation, then determine whether each relation is a function. So all we need is a couple of definitions. First of all, what is a relation? Do anybody know? Yeah, go for it.
Wouldn't it be like how the domain responds to the range? So
to some degree, yes. You see, your relation is simply a set of ordered pairs. So it's some sort of relationship that happens with the inputs and the outputs, right? So you could just call it a set of ordered pairs. That's it. Sorry. So if a relation is a set of ordered pairs, Namely, when you look at x and x comma y, one of these values, one of the coordinates gives you your domain. The other coordinate gives you your range. Which one gives you your domain? The x or the y? The x, the first coordinate.
X.
That's right. So your domain is now what we say the set of inputs, which is x. Therefore, your range must be the set of outputs, which is y. Okay, and there's one last definition that we need to know. The other definition now is for the function. Your function is made up of three things. It's first your domain. Two, it's your range. But something that's a little bit different between the relation and your function is that the function is a rule. It's a rule, whatever that rule is defined to be. It's a rule that takes exactly one input value and assigned it to exactly one output value in the range, right? So I'm just going to squeeze this one here. We're going to say that a rule that assigns exactly one input to one output. Okay, so let's look at part A. Can somebody tell me what's the domain for part A? Bless you. 1, 2, 3, 4. That's right.
2.
What is your range? 7, 3, 5, 5. Now, one thing about sets, bless you, if an object or an element is repeating itself, do we have to write it multiple times? No, just write it one time. So our domain is four elements, 1, 2, 3, 4. The range essentially consists of 3 elements, 7, 3, and 5, where 5 is repeating. So do we have a function? We have our domain, we have our range for each of the relation, but now we want to determine whether each relation is a function. Yes or no? For part A, do we have a function? Yes, why? That's right. Every single input value was sent to exactly one output. So you can have multiple values in the domain, multiple input values that goes to one value in your range. That's okay. The opposite is not true. So domain and range, we figure them out, and we can say relation is a function. And again, it goes by that definition, right? It's a rule that assigns exactly one input to one output. Let's look at part B. What's the domain for part B? 1, 2, and 3. We have 1, 2, and 3. And again, remember, if the value in your domain is repeating, you just got, when you're writing out the objects or the elements in the set, you just write it out one time. All right, what about your range? 2, 3, 4, and 7. Okay, is the relation here a function? No. Can we give a counter argument? Mm-hmm. That's right. If you look at your input value of 2, it was assigned to 2 values in your range, namely 3 and 4, which is no good. So the answer here is no, relation is not a function. If you want to argue your reasoning, you can say that 2 was assigned to both 3 and 4. Remember, 2 was your input value, and it was assigned to multiple values in the range. That's no good. All right. Any questions with part A and part B of problem 8?
My question, well, observation is that, so the domain could have more than one range, but the range can't have more than one domain.
I'm not following. You gotta be a little specific on that.
So basically, based off the given problem, right, is that 3 and 4 could have the same range point, like the same.
Yes. So you can have multiple inputs that goes to just one output value. We call that, if it was like the whole thing, if the whole thing, like let's say 1, 2, 3, 4, let's say all of them went to the number 5 instead, right? Then that's what we call a constant function, because for no matter what value you plug in, you always get back a single value. But yes, there's other functions where multiple values of x just goes to one y value. Think of the parabola x squared, right? If you take -1 squared or even +1 squared, it gives you back +1. So yes, that happens. The opposite, you cannot have the opposite occurring. You can't say, let's say the number 2 goes to multiple values in your range. That's a big problem. It fails something called, one way of visually seeing it is you could use the vertical line test. Abdu, you're in his class? Oh, nice. Gotcha. Sounds good. All right. I guess no questions. We move on. All right. I'm going to slide this up. Let's look at problem 9 now. So again, just keep that definition of a function in your mind. It's made up of 3 things: your domain, the values of x, the range, which is your value of y, and number 3 is a rule that assigns exactly one input to one output. So in problem 9, parts A, B, and C, we want to determine whether each equation defines y as a function of x. So let's look at part A. Part A, we have 5x minus y is equal to 8. One way of showing that y is a function of x is basically that, in short, well, from a visual standpoint, you can show that it passes what we call, using the vertical line test. But from an algebraic point of view, we got to show that for every value of x, there's just one unique solution. There's one unique y. So let's look at this. 5x minus y equals to 8. First, rewrite the equation in terms of y. How would I rewrite this equation in terms of y? Well, we gotta be careful. Well, yes, you're right.
Is it set x to 0 and solve for y?
No. You have to rewrite the equation in terms of y. So Abu was here with us. He gave me the final answer, and I'm just gonna, it's correct. I'm just gonna work it out. You have to first subtract 5x on both sides. So on the left, the 5x are gone. This will give us negative y is equal to negative 5x plus 8. And when you divide by -1 on both sides, you're going to get y equals 5x minus 8. So if you look at this equation, by the way, what type of equation is this?
Slope-intercept.
It's a slope-intercept. It's a linear equation. What is our slope, Christopher?
Our slope will be 5x. So that means
the
that
slope is just 5.
Oh, 5. Okay, pardon me, 5.
Yeah.
So the rise will be 1, and then the run will be 5.
No, it's actually vice versa. The rise is 5.
Yeah.
The run is 1. Okay, we know what's the slope, but more importantly, with m equals to 5, I know that the line should be increasing. Another thing that we should point out here, Christopher, is the y-intercept. What is the y-intercept?
-8.
-8. Okay, so if you look at this linear equation, you can actually graph this. It has a y-intercept somewhere down here, 0, -8. And I know that the line, when I draw it, is increasing. So let's just say that this is our line, hypothetically speaking. Oops, my bad. There we go. Let's say that's the line. No matter what vertical line I take here, it's going to pass what we call the vertical line test. Because if you look at the vertical line that I'm drawing, the blue dashed line, how many times is that blue dash time, the blue dash line is hitting our straight line in black?
Just once.
Just once, right? Every time it's just going to hit it once. What it means for what the vertical line test here is it's showing us that we're demonstrating is that for every value of x, there is just a unique solution. There's just one value of y. So the question here was to determine whether each equation defined y as a function of x. For part A, yes. Y is a function of x. Again, here it passes what we call the vertical line test. Right, all lines, any linear equation in that form, y equals mx plus b, you will have to, any equation that's in the y equals mx plus b form will always pass the vertical line test. And yes, it's going to be, you can say y is a function of x. End of story. Let me show you the counter example first. So I'm going to give you the answer. In part C, the answer is going to be no. Y is not a function of x. It's a counter argument for that one. And I'm not going to show it visually. Instead, I'll show it algebraically. So let's look at part C. Part C, you have x plus y squared is equal to 9. Now, let me guys ask you this question. If you want to determine whether each equation defines y as a function of x, then you first got to manipulate that equation where y is isolated by itself. There's 2 steps that you have to do here. What is the first step that you will do to isolating y? What can I do first to isolate the y by itself? You can't take the square root right away, Christopher, only because it states x plus y squared. So what comes before the square root step? Can you hear me through the music?
Subtract x on both sides.
My bad.
Yeah, you subtract x on both sides. So you get y squared is equal to 9 minus x. And then you're allowed to take the square root. However, be careful when you do take the square root, right? For example, this is just a side here. Let's say I have that a squared is equal to the number 16. What is one solution to that equation? A squared is equal to 16. In other words, what number squared, what number raised to the second power gives you 16?
4
4.
4, right? A can equal to 4 because 4 squared is 16. Is there another solution for A? Is there another number that when I square it, that gives me positive 16?
-4.
-4, right? A can also be equal to -4 because if you take -4 and square it, anytime you square a negative number, the result is always positive. So -4 squared is the same as saying 4 squared, which is also 16. So long story short, when you have y squared is equal to 9 minus x, technically speaking, on both sides of the equation, you apply the square root property, which states that next to the square root of 9 minus x, you're technically supposed to write out plus or minus. So you say that the square root of y squared is y, and is equal to plus or minus the square root of 9 minus x. So in this example here, we can now say that the answer is automatically going to be no. No, y is not a function of x. And you could give a counter argument as why this is true. All you got to do is pick a value of x, any value. What's a simple value of x that I can use here for my counter argument? What do you want x to be? You could choose any number. 2. What number would you could use 2? Let's go even simpler than that.
1.
Even simpler.
0.
0. Definitely 0. Right? If you're allowed to choose the number 0 for calculations, especially when you're doing these counter arguments, then choose it. Makes your life easier. So let's say that if x is equal to 0, then the equation will now say that y is equal to plus or minus the square root of 9 minus 0. What is 9 minus 0?
9.
9. So this is equal to plus or minus the square root of 9. And what is the square root of 9?
Plus or minus 3.
Plus or minus 3. How many solutions do we have here for this one value of x?
2.
2. Is that good?
No.
Nope. This is no good, right? In terms of talking about if y is a function of x, no good. It's not. You can see that for that one value of x that's there, there's 2 values of y. All right. That was our counter argument. Any questions? Just to do part B in this little box that I'm going to draw. We have 5x squared plus y equals to 7. In this example, all you have to do is subtract the 5x squared on both sides. And if you notice on that right-hand side of the equation, do you see any plus or minus? Namely, was there a plus or minus all the way in the front of our expression?
I guess there is a plus.
No, plus or minus, meaning this notation. Do you see that symbol? Yes or no?
No.
No, it's not there, right? So because that plus or minus, I'm scratching it off, because that plus or minus is not there, we didn't use the square root property for part B to solve for y. So therefore, y is a function of x. Namely, this is a quadratic function, which you guys will be looking at very shortly after your exam 1. And you'll look at how to graph these things. But in short, quadratic equations, they will pass, or quadratic functions, they will pass the vertical line test from a visual point of view. Any questions to problem 9?
No.
All right, I'm going to continue. Let's look at problem 10. Problem 10 is now asking us to, so problem 8 and 9, we're basically using the definition of functions. And problem number 10, now we're going to do some computations. It says, given f of x is 2x squared minus 5x plus 8, compute the following. So we want to first compute f of 3. So to compute f of 3, this is going to be 2 times 3 to the second power minus 5 times 3 plus 8. Long story short, you take all of your input values. Obviously, you have to do it one step, one part at a time. But you take your input value, and wherever you see an x, you replace it by that value, by another variable, or even an algebraic expression. So let's do the arithmetic here, since we only had to plug in a number. What's 3 squared?
9.
9. 9 times 2 is what?
18.
18. So this will give us 18 minus 5 times 3, which is 15, plus 8. So if I work out the arithmetic, what is 18 minus 15 plus 8?
11.
11. So that would be the solution to problem, the first part. Let's look at f of negative 3. F of negative 3 is 2 times negative 3 squared minus 5 times negative 3 plus 8. Okay, what's negative 3 squared?
9.
9. 9 times 2?
18.
18. Okay, negative 5 times negative 3 is?
15.
Positive 15. And then we have the plus 8. So what's 18 plus 15 plus 8?
42.
Close. It should be 41. I think you were one number off, just one unit off. So I think this should be 41. And you're done. Let's look at f of negative x. F of negative x, now again, you're treating negative x as an input value. So wherever you see an x, you replace it by the negative x. Wherever you see an x, you replace it with the negative x. So this is going to be 2 times negative x squared minus 5 times negative x plus 8. And then you work out the arithmetic. What's negative x squared? X, but x raised to what? You gotta say the power.
Is that positive x?
Yes, it's a positive x, but x to the what power? You're missing something.
Squared.
Squared. That's right. 2x squared. Okay. Negative 5 times negative x. Excuse me.
Positive 5x.
Positive 5x. And then you have the plus 8. So it's 2x squared plus 5x plus 8. So sometimes when you plug in just a variable term, you're going to get back an algebraic expression. Let's look at the last part, f of x plus h. Your input now is going to be the whole entire piece, x plus h. You're going to replace x by this expression. So you get 2 times x plus h squared minus 5 times x plus h plus 8. And then you're going to have to work out the arithmetic. So I forgot to put a box around this answer. So I'm just going to do this on the side here. So one way so the issue here is that we have to figure out what x plus h squared is. And there's like 2 ways of doing it. The first way is by foiling. X plus h squared means that you have this binomial x plus h times itself. So this was something that I was mentioning earlier. right? That you just can't simply distribute the square into a binomial. However, what you're supposed to do is take the binomial and multiply it by itself. And the way that foiling works is that you take the first term of each binomial and you multiply them by each other. X times X is going to give us what?
X squared.
X squared. What's X times H? That will be the outer terms.
XH.
XH. Then you do the inner terms. What's H times X?
HX.
HX or XH. And then lastly, what's H times H?
H squared.
H squared. Okay. Can we combine any like terms?
X.
Yes.
Yeah, we can combine the XHs. How many copies of XHs do we have?
2.
2. So we have X squared plus 2XH plus H squared. So that's one way of getting the X plus H squared, was by foiling. The second way is to use the idea of something called perfect square trinomials. So perfect square trinomials states that if you have, let's say, a plus b squared or a minus b squared, the way that the formula works is that you take the first term, which is a, square it. You take the last term, which is b or negative b, and square it, right? B squared is just b squared. Negative b squared is also going to be positive b squared. And in between the a squared and b squares, you have what we say 2 times the value of a times b. And for the a minus b, you say it's negative 2 times the value of a times b. So if you were to use, let's say, the perfect square trinomial on x plus h squared, it's going to be exactly x squared, that's your first term, plus 2 times the value of x and h, so 2xh, plus the last term squared. Last term was h, so you get h squared. So you can use foiling, or you can memorize or apply perfect square trinomial. Okay, so we're going to get 2 times x squared plus 2xh plus h squared minus 5 times x plus h plus 8. Now you use the distributive property where you distribute 2 and negative 5 inside the parentheses. And that's how you're going to compute f of x plus h. So this will be 2x squared plus 4xh plus 4h squared minus 5x minus 5h plus 8. If you look closely, there's no other like terms. So this will be your final answer.
Wait, how did you get 4h squared?
Oh, sorry. I was looking at the from the you're right. I was looking at the 2xh, and then when I looked at the h squared, I don't know. I thought the 2 was in front of it. That was my bad. You're absolutely correct. It's 2h squared. Thank you. Any questions to problem 10? Computing functions or evaluating functions for some given input.
Oh, quick question.
Go ahead, Chris.
What I was gonna say, well, question would be like, wouldn't the that's 10D, right? Wouldn't that be like a reminder to like square the polynomials in this case? Because I was questioning, like, in my head, like, why did we get 2x to the second as a positive? And then I noticed that what you did was with this 10D was that since it's within that parameters that it needs to be, squared, that you have to kind of like.
Well, you got to be careful what's your it. First of all, you got to elaborate what's your it. If your it was just a number or a variable by itself, then yeah, square it. But if it's a binomial, if your it that you're defining is a binomial, such as x plus h, then you cannot do x squared plus h squared. You can't just distribute that squared, okay? You have to either use foiling or use the idea of perfect square trinomials. It's something that we talked about when I went over problem 3, okay? When, like, for example, if you have x plus 4 squared, you have to actually square the binomial. Can't square the things that are inside of it. Can't distribute. What you're allowed to distribute, though, is any number that's in front of the parentheses. But you can't distribute the square right away. Sounds good? Okay, let's continue. Let's look at problem 11. Problem number 11 states to evaluate the piecewise functions at the given values. So I don't know if you guys work with piecewise function yet, but on the final exam, you will be expected to graph piecewise functions. So for now, I want to show you how to evaluate them, which is very similar to problem number 10. You see, a piecewise function consists of multiple equations, usually we say 2 or more, over a specific domain, right? So it's 2 or more equations over a specified, actually, it's more of a proper way of saying this, a specified domain. So when you look at the function f of x, it contains of multiple equations. Here they are. And here are the domains for each of your equations. So for example, whenever x is less than or equal to -2, you look at the first equation, 4 minus 5x. For whatever values of x satisfying the domain of -2 is less than x, less than 2, the equation is 7. It's a constant. And whenever x is greater or equal to 2, you use the third equation, x squared plus 3. So here I give you 3 values of x. Based on the piecewise function, you just plug in those values into their corresponding equation. Whichever input value satisfy your domain, plug it into the corresponding equation, and you simplify. So look at part A. We have f of -5. So when x is equal to -5, which equation or which domain are we satisfying? The first domain, the second domain, or the third domain?
Can you repeat the question, please?
Sure. My question was this. When x is equal to -5, which one of the 3 domains are we satisfying? X less than or equal to -2, -2 is less than x less than 2, or is -5 greater or equal to 2? So I'll write it in words. I'll just write it out here. When x is equal to -5, we have to compute f of -5, right? So my question is this. Look at your domains. There's 3 of them. Which one of the domains, when I plug -5 in for x, which one of those domains is true? The first domain, the second, or the third? You should be able to read inequalities.
I think it's the first one.
Yeah, it is. Yeah, that's right. That's correct. When x is equal to -5, we have that -5 is less than or equal to -2. So we have to plug -5 into that first equation. The corresponding equation for the domain was 4 minus 5x. Therefore, f of -5 should be 4 minus 5 times -5. And you work this out. What's -5 times -5?
25.
25. So you get 4 plus 25, which is
29.
29. And that's your solution. Let's look at part B. Actually, I'll do part B on the bottom. So part B, we have f of 5. So when x is equal to 5, which one of your, when I plug 5 into our domains there, which domain is going to be true, or which inequality is true?
I guess the third one.
The third one, that's right. When x is equal to 5, 5 is definitely greater or equal to 2. So that implies we use the third equation. Okay, the third equation reads x squared plus 5. Therefore, by substitution, we get 5 squared plus 3. What's 5 squared plus 3?
28.
28. And that's it. Let's look at part C. Part C, I want to evaluate f of -1.58792. So look at that value of x. That value of x would satisfy what inequality? Which one of the inequalities?
Second one.
The second one, that's right. -1.58792 is sandwiched between -2 and 2. So we use the second equation there, right? So we have -2 less than -1.58972. This is 792, my bad. So look at equation 2. Equation 2 is just a number. It's just a constant. So no matter what value of x you plugged in, whether it was 0, 1, 1.5, -1.5, your answer is always going to be, 7. And that's your answer. Those are your answers for problem 11. You just look at the values of x that you have to compute, see which inequality it will satisfy, and plug it into take that value of x and plug it into that corresponding equation. Any questions?
No.
Okay, so I have about 5 more problems I want to show you. Let's see if I could try to get this done in like the next 20 minutes or so. So we're going to move on to problem 12. Problem 12 states, let f of x equals 2x squared minus 5x plus 8. So it's exactly the function that we worked with from problem 10. And we have to compute and simplify the difference quotient. Do anybody know the formula for problem 12? What is the difference quotient? Anyone? What is the difference quotient? You can look back into your notes if you need to. Sure.
Is it F times X plus H
That's right.
minus F of X and then all over H?
That's right. It's F of X plus H minus F of X divided by H, as long as H is not equal to 0, right? So one thing in math to note of is that when you're dealing with the real number system or in general, you don't divide by 0. Okie dokes. So F of X is equal to 2x squared minus 5x plus 8. We have to compute the difference, compute and simplify the difference quotient. So here's how this works. First, you got to figure out what's that F of X plus H piece, right? First, find F of X plus H, right? Which means that wherever again I see an X, replace it with X plus H. So that would have been 2 times X plus H squared minus 5 times X plus H plus 8. Fortunately for us, we did this in problem 10, right? So if you ever have to go back and, see how I did that, just revisit problem number 10. So long story short, when we do compute F of X plus H, based on the results from problem 10, we saw that this was 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 8. Okay. So again, this was by the results of problem 10b. All right, now that you've got your F of X plus H, you can go ahead and make some substitutions into your formula. What I like to do is, because the F of X plus H and the F of X is separated by a minus sign, I use brackets to separate their corresponding terms. So for the F of X plus H, I start off with a bracket. I'll say 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 8 minus the original function. F of X is your original function. So the terms of the original function were just 2x squared minus 5x plus 8, all divided by h. But just note that when I did the substitution here, the replacements, the F of X plus H terms are in their own brackets, F of X terms are in their own brackets. The reason why I do it this way is because, again, there's a minus sign there. So whatever terms that they have in common, the minus sign tells me I can cancel them out. So what terms could I, if you look at your expression there, what terms can we cancel or cancel out?
Two x squared.
Mm-hmm. What else?
Negative 5x.
Negative 5x.
And 8.
And 8. So notice that the terms that we are canceling out are the terms 2x squared, negative 5x, and 8, which came from exactly the original function, right? The terms of the original function should be canceled out. The only terms that should be remaining are terms that involve an h. For example, the 4xh plus 2h squared minus 5h divided by an h. Now, because all the terms in the numerator have an h inside of them, you can factor the h out. If I factor an h out of the numerator, then what terms will go inside of the parentheses?
Four x plus 2h minus 5.
There you go. Very good, Emily. So as long as h is not 0, right? Remember, that's the only number we can't divide by 0 by. The h's are canceled. And whatever's inside the parentheses now is your final answer. So we say 4x plus 2h minus 5. How's that? Is there any questions to problem 12? I think this is definitely going to be on your first exam, but it's also there on the final.
I had a question.
What's up, Christopher?
So my question was like, when it says difference, right? Is it regarding like subtraction, or is it just like the
It's the formula. The formula is called a difference quotient because in the numerator, long story short, you're taking the difference between two different output values, f of x plus h and f of x, essentially. This difference quotient, by the way, the formula that you're actually computing, it's a fancy way of computing slopes for functions that don't resemble. I mean, you could use this for lines, but this is the formula we use to compute something called the average rate of change between 2 points of a non-linear function. That's what it's mostly used for. You could use it for linear functions as well, but that's just using slope. Sounds good? You're making a lot of noise in the background there, Chris. Thank you. Okay, so that's problem 12. Let's look at problem 13. Problem 13 states, let f of x equals x minus 7, let g of x equals x squared minus 49, simplify and state the domain of f of x over g of x. So one thing to note, just like in problem 12, look at one of our statements. It states that h cannot be equal to 0. The reason why h cannot be equal to 0 is because we cannot divide by 0. So just note that when you're dealing with the difference, when you're dealing with the quotient, one function divided by another, there's going to be values of x that will make the bottom function be 0. Those are the values that you have to exclude from the domain. As Scott Hall used to say, those are the bad guys. Those are the bad guys. So you got to get rid of them. So let's see what happens. So let's write this out. Let's write this out as actually a fraction, as a rational expression. F of x over g of x is simply going to be x minus 7 over x squared minus 49. Now, typically speaking, for this type of problem, it does say to simplify. And if you want to simplify it, you're canceling out any common factors that the top and bottom have. If you want to figure out if they have any factors in common, you have to write out the top and bottom in both factor form. For example, the numerator, x minus 7, in that binomial, there's nothing to really factor, right? The greatest common factor between x and negative 7 is just 1, so you leave it alone. But look at the denominator, x squared minus 49. Can I factor the denominator of this function? You want to go for it, Emily? I saw you had your mic unmuted.
Yeah, I mean, I kind of did, but now I don't.
Give it a try. I'll help you out. I'll walk you through it.
Okay, so like, I know that you're going to have two sets of parentheses, right?
Mm-hmm. You're right. Absolutely right about that.
And then it will be like X.
Continue.
X minus.
X minus.
I want to say 7 because that would be the square root of 49.
That's right. You're going to get X minus 7. That's one factor of it. What do you think is the other one?
X plus 7.
There you go. You see, the way that you factor X squared minus 49 is that it resembles a difference of two perfect squares, right? So in other words, if you have A squared minus B squared, the difference of two perfect squares is just A minus B times A plus B. And that's it. That's how you factor it. Very good. Okay, so now that it's in its factor form, right? Again, looking back at the first formula I have, f of x over g of x, again, there's going to be values of x that makes this bottom 0. You can solve for it algebraically, right? Just take each of the factors, like x minus 7, set it equal to 0, and do the same thing with the other binomial, x plus 7, set it equal to 0. When you solve for x, those are your bad guys. Those are the bad guys. So x minus 7 equals 0 would imply that x is equal to what value? If you were to solve the first equation.
7.
7. And for the second equation, x plus 7 equals to 0, x would equal to what value there?
-7.
-7. So for this problem, x cannot be equal to -7 nor +7. They're the bad guys, right? So I'll just put this in quotes. They're the bad guys. And because they're the bad guys, we take them out of our domain. All right. So one thing to also note is that if you have domain issues with the original function, right? X minus 7 over x squared minus 49. Then when you look at the simplified function, the function in, when you simplify the function, the bad guys carry over, right? So look at your expression in factor form. X minus 7 over x minus 7 times x plus 7. Is there any binomials that we can cancel out? Go for it, Emily. I saw you had your mic unmuted.
X minus 7.
That's right. The x minus 7s are gone. However, on the bottom, we have x plus 7. What do we have on the top?
1.
1. We have a 1 as a placeholder. So it's 1 over x plus 7, where x cannot be equal to -7 or 7, right? So bad guys just carry over. My bad. In other words, if the original function have domain issues, then the simplified function has the same domain issues. Okay, so that's it being simplified. Now we just got to state the domain. There's many ways you can state it. You can do something called set builder notation, interval notation, graphically or in words. Because we're introducing the topic, I'm going to write it only in words for now. So we can say that the domain of f over g is all real numbers except when x is equal to -7 and x equals +7. Your domain could be anything from a number line point of view, but these two values. You can get really close to them. You can have something like negative 6.9999. That's still valid. But as long as you're going to hit -7 or you hit 7, it's over. Game's over. You hit the bad guys. Any questions to problem 13? All right, let's look at problem 14. Problem 14 states to find the domain of h of x equals the square root of 20 minus 4x. So let's just look at the most basic square root function, the square root of x. If you want to evaluate the square root of x, what type of numbers do we use? And what type of numbers we do not use? Anyone want to take a try? When you have the square root of x, just the square root of x, what type of values can I plug in for x? Can I get an example?
Perfect squares like 25.
It doesn't have to be perfect squares. You can plug in 25, yes. You can plug in something that's not a perfect square, like the number 3, the number 2, the number 99. They're not perfect squares, but they all have something in common, right? They're all positive. You can also plug in 0. In the real number system, you can't plug in negative numbers. So when you're dealing with the square root of x, the values of x must always be greater or equal to 0. So algebraically, if you want to determine the domain for a function like h of x, the square root of 20 minus 4x, then that implies that that entire, whatever algebraic expression you have inside that square root, your radical, it must be bigger or equal to 0. So the very first thing is to just take the algebraic expression, 20 minus 4x, set it greater or equal to 0. And now you solve for x. You subtract 20 on both sides. So the 20s on the left are canceled. This will give you negative 4x is greater or equal to negative 20. And then you divide by negative 4 on both sides. The negative 4s on the left will cancel. That gives you x. Negative 20 divided by negative 4 is 5. But when you divide or even multiply by negative numbers, what happens to the inequality symbol?
It flips.
It flips, that's right. So if you had greater than or equal to, it now becomes x is less than or equal to 5. So we write this out in words now. We say that the domain of h is all real numbers satisfying x is less than or equal to 5. In other words, if I plug in a value like 4, right, h of 4, that would have been the square root of 20 minus 4 times 4. That would have been 4 times 4 is 16. 20 minus 16 is 4. So the square root of 4 is 2. And that would have been good, right? You can see that when x is equal to 4, it's part of our domain. Similarly, when x is equal to 5, this will give you the square root of 20 minus 4 times 5, which is the square root of 20 minus 20, which is 0, which is 0. That's still okay, right? Because we're getting back either a 0 or a positive number. But if now I choose something like h of I don't know. Let's just make this 11. Then this is equal to the square root of 20 minus 4 times 11. But 4 times 11 is 44. Take 20 minus 44, you get the square root of negative 24. This here, unfortunately, because there's a negative inside that radical, it's undefined. Does not, D&E, does not exist in R, in the real number system. Okay? So that's why it's very important to know your domain of functions, because not all functions are perfect, where the domain is going to be everything. It's not going to be the entire number line, or it won't be all of R. It's going to be limited, meaning that there's only going to be certain values of X that we can plug in. And then there's just going to be these 1 or 2 or more values of X that we cannot plug in, unfortunately. Sounds good? Give me 1 second. I'll be right back. Oh, sorry, that's 233. Keep going. Yep. You see the door open. Go on. All right. Any questions with problem 14? All right. So I wanted to do 2 more problems, problems 15 and 16, which talks about transformations. I'm just going to do them informally because I'm running out of time. So I won't write out all the rules, but we're just going to go about it. When you look at problem 15, you comparing y equals 2 minus the absolute value of x minus 1 to the equation y equals the absolute value of x. Now, do anybody know what the graph of y equals the absolute value of x looks like?
V?
Yeah, it's like a V shape, right? It's a V shape where your anchor point is at the origin. So let's say that's 0, 0, the origin, and it should be a V shape, something like this. So we're going to discuss the transformations and then sketch our graph. So we're going to have to break this all down. So let's look at first at positive 2. I'll put this in quotes. Now, is the positive 2 inside or outside of the absolute value bars? Look at the location of the 2. Is it inside or outside of the absolute value bars?
Outside.
It's outside. This implies the transformation rule states that we shift from the anchor point, the point that's in blue there, we shift it 2 units up. Okay. Now let's look at the minus 1. Is the minus 1 inside or outside of the absolute value bars?
Inside.
It's inside this time. When you have a minus 1, it implies that we shift 1 unit to the right. Now let's look at the negative. Is the negative inside, the one that I circled? The negative that I circled, is it inside or outside the absolute value bars?
Outside.
It's outside. The outside, the negative talks about reflection, namely flipping. So the negative would imply flip in the x-axis or reflect in the x-axis. Basically, you flip it upside down. So this is how it's going to look. Starting with your anchor point, 0, 0, you would have to figure out the new anchor point, which means that you would have went 2 units up, then 1 unit to the right. So that order pair that I plot in black, what would that order pair be? If I went 1 unit to the right of the origin and then 2 units up, what would that order pair read as? Or how do you read that order pair?
1, 2.
1, 2. So technically speaking, at that order pair, that's our new anchor point, right? I'm going to call that our new anchor point. And now you just got to plot a V-shaped graph. The thing is, when we say reflecting the x-axis, we're flipping the V-shape upside down. And it will look something like this. So when we put it all together, right, just going to draw what that graph looks like. Here's the order pair 1, 2 again. And now you're just drawing that V shape upside down. And that's it. Any questions? Alrighty, everyone. We got one more problem to do. And then we can wrap it up. We did a very good job today. So let's look at problem number 16. Problem number 16 states, discuss the transformation and sketch the graph of y equals the square root of x plus 2. So what we have to do is compare these graphs to their parent functions, like y equals the square root of x. Y equals square root of x begins at the origin, and it looks like a graph where you're going fishing. You're throwing the hook or the rod, the wiring part of the rod. So it's like you're throwing it into the sea, but it doesn't go down yet. It's like half of a parabola rotated 90 degrees. Anyways, this is y equals the square root of x. And we want to sketch the graph of y equals the square root of x plus 2. So we're just going to figure out what this plus 2 implies. Well, first of all, where is that plus 2 located? Inside or outside of the square root?
Inside.
Inside of it. Now, as you can see in the previous example, when we had a -1, it would tell us that we have to shift 1 unit to the right, meaning we're shifting our anchor point 1 unit to the right. So this implies that I have to shift 2 units. But because there's a +2, we go in the opposite direction. So what's the opposite of the right?
The left.
The left. So we shift 2 units to the left. And if we shift 2 units to the left, the new anchor point will now be -2, 0. And you draw your graph. Oops, sorry. I don't know why it keeps doing that. I'll just leave it the way it is here. So we draw our graph. In blue, we have y equals the square root of x plus 2. And we're done. We discussed our transformation here. We use it to sketch now the graph of y equals square root of x plus 2 by comparing it to y equals square root of x. Do anybody have any questions for me for today? You all did fabulous, and I wish you all the best on your exam. But if you have any last minute questions, please let me know, or else I'll end the meeting.
So if the you see how there is +2, if it was -2, then the blue point would be in the positive side, right?
That's right, somewhere around here. Let's say that's 2, 0. This would have been y equals x minus 2.
Okay, thank you.
I draw it smaller, by the way, because I was trying to, I didn't draw it to scale, but yes, that's what it'll look like. Anybody else? Yes, you should definitely get both recordings. Raphael is in charge of that part. He will, he'll make sure that it's distributed to everyone. Be sure to check your Lehman email address later tonight or later today. Anyone that's enrolled in MAT171 or 172 will receive that recording. Anything else? Chris, you got a question?
Yes, I do. So if the function was, if it was y equals square root of x minus 2, wouldn't the graph be on the opposite side of the coordinate?
If it's minus 2, you go 2 units to the right. So look at the graph closely. This was somebody else asked me the same question. I think it was Mahmoud. If you look at y equals square root of x plus 2 versus square root of x minus 2, plus 2 means go 2 units to the left. Minus 2 meant to go 2 units to the right, as long as they're both inside of the function. If they were outside of the function, then I would have went 2 units up or 2 units down, right? So like, for example, if this is, this here in red would have been y equals 2 plus the square root of x, because the 2 is outside of the square root. On the other hand, here in red would have been y equals square root of x minus 2, where that minus 2 is outside of it, okay? It depends on where the real number, the constant value is located. If it's located inside of your function, you either go right or left. But if it's outside of your function, you go up, down. All right?
Yes,
are you there, Chris? You're welcome. Anybody else? Alrighty, you all are free to leave the meeting. Enjoy the rest of your day. Thank you so much for your participation. And again, best of luck on your upcoming exam. Hopefully we do this again for, we'll call it review session 2 next month. Take care, everyone. I'm going to stop the recording now. Sorry.
Thank you.
You're welcome.
Thank you so much.
You're welcome.